Hi, so today in this video we are going to study the first topic of physics, which is scope of physics. Now in general science we have two fields, which is biological field and the physical field. When talking about biological fields, we have humans, which are living matters, animals, insects, microorganisms. You can think of anything that is living, like plants as well. And when thinking of physical science, physical science is the behavior and properties of all the non-living matters. For example, you can think of anything like a spaceship which goes to space, which helps to transport humans to space. These all things which are related to non-living matter are related to physical sciences. Now on the next page you can see what physics is about. So physics is about matter and energy. Matter is something that occupies space. It can be anything. It can be this human which you are seeing here. By the way, this is Isaac Newton, Sir Isaac Newton, who discovered gravity. And you can think of matter as something that has some space in our world. Like you can think of books, you can think of your mobile phone, or you can think of a desk or chair, anything that occupies space. That is called matter, and which you can see as well. While on the other hand, you've got energy. Energy is something that you cannot see. You cannot see or figure out that what this thing is. By the way, this thing is actually an empty space, and it is only an empty entity where you can't see anything. Basically, in this empty space, there are lots of energy which are present, which we can deduce by ourselves, but we cannot see it. So it is called energy. While on the other hand, the study of these two things, which is interaction of matter or matter only you can say, and energy, is called physics. So in the end of this chapter, there are several types of physics mentioned. For example, there is particle physics, which is related to some particles of the physics. And in the second chapter, there is nuclear physics, in which we deal about atoms, about electrons and protons. And in this chapter, the same series, there is a third field of physics which is called astrophysics, and we deal about stars and plasma and all that. And in molecular and atomic physics, we talk about matter and all that stuff which is about humans. This is all from the first chapter, and I'll meet you in the chapter in the second video, in which we go through the second chapter, which is about Islam and science. This is all. Thank you. So in this video we are going to discuss that what is the relation between Islam and science. But before moving on, we are going to look at some of the scientific researches. Now looking at some of the scientific researches, we should know that all these scientific researches are actually promoted by Islam. For example, as you can see that this book was revealed 1400 years ago, and it said that and he, Allah, has placed the moon as a light in them. As you can see here, there's a picture of a moon, and as we all know that moon is a source of light for us, and it gets light reflected from the sun, and it reflects the light at night. And so as you can see, this book, which is Holy Quran, 1400 years ago and still valid. But the thing to notice here is that this book was revealed 1400 years ago, and it gave this sign of moon as a source of light. Now the thing to catch here is that behind all of these things in our universe are a creator. And let's look another example here from Holy Quran, which is he, Allah, has made the sun as a lamp. And again here, sun, as we all know, is a source of light for us, and it gives us light energy from which we live, we breathe. And as we all know that as sun is a source of light for us, we should also note that this was mentioned in Quran 1400 years ago. And so general idea of this chapter is to actually tell you that Quran and Islam has also backed up science before it was even discovered or invented. So the main idea here is of a creation. As you think of a creation you see around yourself, for example, let's think of a mountain. Right, here's a mountain, and the general idea behind this is that that this hasn't been created in vain. Behind this creation there is a creator, which is Allah subhanahu wa ta'ala, and that has been mentioned in Quran 1400 years ago. And so in some of the verses of Surah Al-Imran, it is being said that surely in the making of heavens and the earth and the alternations of night and day, as you see, when in our daily life, when life goes out, we say it's night. When sun comes on onto our head, we say it's the day. So that alternations of day has been discussed over here. Alright, there are signs for people of understanding, those who remember God standing and sitting and on their sides. It means that Allah subhanahu wa ta'ala has been mentioned, and Allah subhanahu wa ta'ala is creator of this alternations of night and day. And here are presented the followers who remember God when they pass their life, when they stand, when they sit, and when they actually go on with their lives, they actually remember God. And so let's go ahead. So what's the main idea of this chapter? The main idea of this chapter, that whichever the creation in our life, whether it be sun, whether it be anything as small as moon, whether it be anything, whether it be gravity, which actually attracts you to the center of the earth, that is gravity. Anything, any phenomena has been created by a creator, and that creator is Allah subhanahu wa ta'ala. So the main idea is that all these things you see around yourselves have been made by a creator, but not in vain. Like, it hasn't been made already when the world was created. It is a creation of a creator. And that is all from this video. If you liked it, make sure to like and share it with others. And let's meet you in the third video, in which I'm gonna discuss some of the contributions of the Muslim scientists in the Islamic world. Alright, so today in this video, this topic is 1.3, the topic 1.3 of the book, physics book. Uh, First of all, let me just hide this window. Alright, so this 1.3, this topic is actually about the contribution of Muslim scientists in the Islamic world. And the first scientist we are going to look at is Al-Khwarizmi. Now, looking at his achievements, the most famous of his achievements was that he founded analytical algebra, which is used in today's world in physics, in mechanics, and all these fields which are related to physics. On the other hand, he wrote a book which is called Hisabul Jabr al Muqabla, which you have to learn. And the third which he invented was the term logarithm. So you can actually call him the undisputed inventor of of this term logarithm, which is nowadays used in uh, basic calculations and doing other math stuff. Looking at other scientists, the second scientist on our list is Ibn al-Haytham, and he was a famous mathematician as well. And most famous of his achievements was that he invented a pinhole camera. As you might have seen, in a pinhole camera there's actually a box, and inside it is just a small hole, and some light from the sun, this is the sun here, some light from the sun actually comes into this hole, and on the other side, which means from here, you see from this hole, and this light actually reflects from this hole to your eye, and in this way you can actually see a solar eclipse or uh, other reflection of light. His main study was in the field of light actually, and he wrote a book which was called Kitabul Manazir, and you gotta learn this as well. Looking at our next scientist is Al-Biruni. Al-Biruni was a famous scientist who wrote a book which was later known as Encyclopedia of Astronomy, and he was also a famous mathematician and physicist. Apart from that, major part of his life was invested in astronomy. Looking to our third scientist, a third scientist is Al-Razi. Now, Al-Razi was also a famous mathematician, but he was also a doctor, and he wrote 200 monographs in the field of medicine that are still valid today. And this is actually his achievement, that 200 books or monographs, as you can say. He wrote 200 years ago, or like not even 200, it's almost a century or 2 centuries year ago. They are actually valid today as well. Now looking at our last scientist is Ibn Sina. Now Ibn Sina was also a famous mathematician as all the other Muslim scientists, but apart from that, like our previous scientist, which was Al Razi, he was also a good doctor, and apart from being a doctor, he was also a good chemist, and he also tried to mix metals to form gold. Like he tried to mix metals like iron or steel, and he tried to make gold. And he was also famous for his work in chemistry, and apart from that, he was also a good mathematician like all the other Muslim scientists. Now let's summarizing all the work of our Muslim scientists. First of all, you have to learn all the things like the books they wrote, like Hisabul Jabr and Al Muqabra, and apart from that, the things they invented. If you want to learn more about these Muslim scientists, you can check it out on the internet and research for it. But if you just need to go get over with it, you can just learn the name of the books and the achievements they achieved. This is all from this video. If you liked and learned, make sure to like and subscribe. Thank you. Alright, so today in this video we are going to talk about measurement and system of units and how the units are stated. So first of all, talking about the base units or basic units as you call it. The basic units are length, mass and time. As you all know that length is measured in meters, while mass is normally measured in kgs, or maybe you can call grams, and time is measured mostly in seconds. Now in this chapter we are going to talk about three different systems. The first system is FPS. Now FPS means F, we are going to write foot for F. For P we are going to write pounds. As you know, pounds is widely used in the UK. And S is for second. Now as you can see the order, the FPS, as F comes first, then P comes second, and S comes third. The order is: for foot there is length, and for pounds there is mass, and for time there is second. Now let's look at the next system, which is MKS. And as you can see, M is for meters. I'm gonna write MET here. K is for kilograms. I'm gonna write kg. And S is for seconds. Now you can see the order over here. Meters is a unit of length, while kg is the unit of mass, and S is the unit of second, is the unit of time, which is second. So I'm gonna write T here. So the thing we can deduce from this is that the standard unit for all these systems is in this order, which is L, then M, and then T. Alright, so this is the standard order here. The first system we saw was foot, pound, second. The second was meters, kilograms, and second. And third is CGS. C is for centimeters. I'm gonna write centimeters, cm. G is for grams, which is I'm gonna write a capital G, and S is for second. Now again the order is length, then mass, and then time. And as you can see, all the orders are in LMP form. Another thing to notice here, that in all these systems the unit for time is second, like in the FPS and in the MKS and in the CGS. Another thing to notice is that at the end of all the system there is an S, which means second, and in MKS there is an S as well, and in CGS there is an S as well. So these are all the system of international base units, and the thing to do here is to learn all these systems and the units of all the quantities mentioned here. Thank you. This is all from the video. If you learned, make sure to like and subscribe. Alright, so this is 1.6, which says measurement of time, and in this chapter we are going to look at the devices which are used for measuring time and the units in which time is measured. But first of all, the standard units of time, let me write the standard units of time over here. The first unit, the longest unit in fact, is year, in which we measure time, like 2 years, maybe 10 years, with 10 years which is called a decade, 100 years which is called a century. So the first standard unit of time is years, and after years comes months, and after months, comes weeks, and after weeks come days, after days come hours, and hours become minutes, and minutes become seconds, and it ends like that. The SI unit of time is second particularly, and the standard unit we mostly use in calculations is actually second in time. Now let's look at most of the devices which are used to measure time. The first device we are going to look at is the atomic clock, which is the most accurate clock of all. Now as you can see in this picture, the time is measured from hours till this unit, which is after the second. Now at the top you can see the date plus the month and the year, and this shows that how much accurate is the atomic clock. Apart from that, the accuracy of atomic clock is also proved by the measurement of its time. It can measure up to 10 into uh, 10 to the power of minus 10 seconds, and 10 to the power of minus 10 seconds, if I write here, must be 0.0.0.0, and it's like 9 zeros after this zero, and it can measure the time up to that point. It is that much accurate. Now moving on to our second device, which is a digital stopwatch. We mostly use that in sports, or maybe measuring laps, or it is just used to measure normal time limits, but it is not that much standard, so it is not that much used, but it can measure up to plus minus 0.1 second. That is its accuracy. Moving on to our third device, which is the analog stopwatch, which you must have seen in most of the films which are related to race cars, naming Ford versus Ferrari and all these films which are related to racing and stuff. These watches are mostly used for measuring time in seconds. As you can see, this is 5 seconds, this is 10 seconds, this is 15, and in that case you can see the 60 over here, which says 1 minute. Now 60 seconds, as 60 seconds is equals to 1 minute, it can measure time up to the accuracy of zero point 0.1 seconds, and that is its accuracy, minus plus zero point 0.1 second. The fourth clock we are going to look at is the ticker tape. Now ticker tape is a bit of a old clock which is not that much used, but it is still used in some of the physical experiments. As you can see some of the dots here, it shows that as the distance between the dots is increased, like you can see the distance here is much lesser than this one. This distance is actually lesser, but this one is actually more farther away, which shows that the vehicle is actually getting faster. uh, Apart from that, the accuracy of ticker tape is that it can measure time up to plus minus 0.02 second. The fifth clock on our list is the pendulum clock, which is not used that much actually, but it is used mostly as wall clocks. The sixth clock we are looking is radioactive decay clock. Now this clock has been used in radioactivity, and most of the use of this clock has been in the field of measuring isotopes half-life. Apart from that, people also use Geiger counters and Geiger clocks, but radioactive decay clock is also in use. So let's revise from the start. The number of clocks that are listed in this chapter is the atomic clock, you have to learn its accuracy, which is 10 to the power of minus 10. The second one is the digital stopwatch. Its accuracy is plus minus 0.01 second. And the third is the analog stopwatch. It measures time in minutes and seconds, and its accuracy is plus zero point 0.1 second. The fourth one is the ticker tape, which measures up to plus minus 0.02 seconds. And the fifth clock is the pendulum clock, and the sixth one is the radioactive decay clock. And you should also learn the use of radioactive decay clock, which is mostly used for measuring an isotope's half-life. That's it from the video. If you learned and liked, make sure to subscribe, and if you want to learn O levels, make sure to check out the playlist in the description. Apart from that, I have also added the playlist of this first chapter in the description. Make sure to like and subscribe. Thank you. Hi, so in this video we are going to see the international system of base units, but before I would like to tell you that there are actually two quantities. First of all, let me write a Q here for quantity, and there are actually two quantities, two types of quantities. One is called base quantities or base units, and the second one is called derived quantities. I'm gonna write a DER for it. Now what base quantities are is that they are the standard quantities which we use mostly, like time, which hasn't been derived from something and it is like the real thing. uh, co- Apart from that, the derived quantities are the quantities that are actually taken out from other quantities. One example of a derived quantity is velocity. Velocity is taken from time and distance, like distance upon velocity is equals to distance upon time. So the first two base quantities was distance and time, and when they were both divided, they gave us velocity, which is a derived quantity. Now moving on to our base quantities, then in international system of base units we have seven base quantities, and you have to learn that. First of all, our first base quantity is length, which as you all know has the unit of meters. We use kilometers as well. 1 meter is equals to 1 upon 1000 of a kilometer, or 1 kilometer equals to 1000 meters. Mass has the standard unit of grams. We also use kilograms. Electric current and has the unit of ampere, as we all know. Time has the unit of seconds. Temperature has a unit of degree centigrade. Intensity of light has a unit of CD, which is candela. I'll write candela over here. And our last is the amount of substance, which is mole. Now moving on to our derived quantities. Our derived quantities is volume. Volume is meter cube. Its unit, and uh, it is a derived quantity. Apart from that, force is has the unit of Newton. Pressure is also a derived quantity. Pressure equals to force upon area. It's also a derived quantity which has the unit pascals. We uh, shortly we use it for PA. Newton has been shorted by N. Work, which has the unit joules. Work is actually the same as energy, but it is derived. The amount of work done is derived from the formula of energy. It has the formula joules, which is shorted for J. Electric charge has the unit coulombs, and the short unit for it is C. Velocity has the unit of meters per second, and these are all the derived quantities. Apart from these, there are seven base quantities which you have to learn and their units. And this is all from this video. If you liked it, make sure to like and subscribe. Thank you. Hi, so in this video we are going to discuss about the dimension and first of all, before moving on to explaining dimensions and how to calculate dimensions, I'm going to tell you that what actually dimension is. Well, dimension is actually a thing which is used to denote the nature of physical quantity. Moving on, dimensions are actually expressed in the form m, l, t, and what m is actually, it's a physical quantity which is mass, l is length, while t is time. Now mentioning their units, for mass we have grams, for length we have meters, and for time we have seconds. Now in physics we denote every other quantity, for example a quantity which is speed, or you might say maybe density. Let me write density over here. This density and here speed, both of them are actually a physical quantity, and we actually denote them or represent them in this form which is called mlt. Now I'm going to show you how to actually represent a quantity in this form, which is mass, length, and then time. Now first of all, let's think of a question. So the question is, denote the dimension of speed. Now speed here is a physical quantity, but before calculating the dimension of speed, you have to write the formula of speed here. The formula of speed is, as you all know, distance upon time. I'm going to write it capital D here for distance and a capital T for time. Now here is the formula for speed. What you have to do to figure out the dimension is that you have to actually take the base quantities. The base quantity is a distance. A base quantity is something which has only a single unit. For example, distance, it is not a derived quantity, as I told in my previous videos. It is a base quantity. And time, it is also not derived, but speed is derived from this distance and time. Like when we divide distance with time, we get speed. So speed is a derived quantity, but d and t, both of them are base quantities. Now when figuring out dimensions, the first step you take is to write the formula. The second step, as this is a physical quantity, you have to write the dimension of this physical quantity. And as this is a base quantity, I'm gonna write a b here. Time is also a base quantity. You are going to write the units of these. Now you have to learn one thing, is that whenever you are given a question to calculate a dimension, you are only going to write the units for the base quantity. Now moving on to our second step. Our second step shows us that d has a unit of meters, and in this mlt, where can you actually see d, which is distance? Obviously in the category of length. Alright, so you are going to write l here. And time, we have got the time over here, so we are going to copy it as it is. So the answer here is l upon t, and you are going to take the t up, so it's gonna become l multiplied by t to the power of -1. As you have removed this division sign, you are going to multiply, plus that t has a power of -1 as well. So when you're going to multiply, you are going to get l into t to the power of -1, and this is the dimension of speed. Now moving on to our another question, or figure out the dimension of acceleration. I'm gonna write this figure plus acceleration. Alright, ACC for acceleration. Before moving on, as you all know, the first step is to calculate the formula, and the formula of acceleration is equals to, this would become velocity as a whole in dimension, so the formula would become velocity upon time. Alright, velocity upon time, you are going to write the dimensions again. Now as you can see, t is a base quantity, but here v is a derived quantity. So what you are going to do, you are going to take out this derived quantity, which is velocity, and you are going to calculate the dimension of velocity first. So the second step here is to calculate the dimension of velocity, and obviously we are going to write the formula of it. So velocity equals to distance upon time, and there you go, distance has length, while t you're going to write time. Alright, so the dimension of velocity is again gonna be l to the t, l into t to the power of -1. So this is the dimension of velocity, and we are going to calculate the dimension of acceleration. So, and we are going to put it right over here, l to the t, l into t to the power of -1 upon t, you are going to remove the sign of division, and the t goes up and it becomes L into t to the power of minus 1 into t to the power of minus 1, and the final product is gonna be L into t to the power of minus 2. That's it. Thank you. Make sure to like the video and subscribe. Hi, so in this video, we are going to cover the last chapter of the first unit, which is the scope of physics. So the last chapter is about significant figures and the rules of them. Now we're going to look at some of the rules of significant figures, in which we declare some of the answers or products or some of the answers. Now, looking at the first rule, our first rule says that all non-zero numbers are non-significant. For example, 1, 2, or 3. Even 123 itself has three significant figures, which is 1 itself, and 2, and 3. Little test for you. Pause the video and guess the answer for yourself. And the question for you is, how many significant figures are in 1234? Alright, so the number of significant figures in 1234 is obviously 4, as all non-zero numbers are significant. Now moving on to our next rule, which is zeros between significant numbers are significant as well. For example, just as we reviewed before, that 1234 has four significant figures. For example, if a zero comes right here, let me write it now, it becomes 12,000. A zero here, 12,034. Now here there are five significant figures, as the zero here is in between these two significant numbers, or you can say these four significant numbers. So another test for you, and I'm gonna let you guess that how many significant figures are in 1230, and how many significant figures are in 1200 and 12,230. So alright, so the number of significant figure in the first number is 4, as all non-zero numbers are significant, but this 0 is non-significant as it is not between the significant numbers. And in the second number, which is 12,030, there are 4 significant figures as well, but in this case this 0 is significant while this 0 isn't significant, because it is after the whole numbers, and this 0 is significant because it comes in between the three whole numbers. Now moving on to our next rule, which says that zeros before and after decimal are non-significant. Zeros before decimal is a 0 like this, so this 0 is, for example, not significant. Now zeros after that are not significant as well, but if in case there is a number here, let's say 1 or 3 or both of them, they are significant because they are whole numbers, but these four zeros are non-significant. Let's consider another case, which is 0.0145. Now in this case there are a total of three significant figures, which is 145. Another test for you, and you to guess that how many significant figures are in this number. Alright, so there are actually four significant figures in this number, as these two zeros are non-significant while the whole numbers after these zeros are significant, and the number of whole numbers is 4. So there are four significant numbers in this whole number. Moving on to our next rule, which says that zeros after whole numbers are non-significant. Whole numbers are all non-zero numbers. For example, 12,300, that's a whole number, and what it says that after these three whole numbers, the zeros after that are non-significant. For example, this part is non-significant. Let's consider something like 13 million. Alright, I'm writing 13 million over here. So in this case, only the 1 and 3 are significant, and the rest of the numbers or zeros are non-significant. And the test for you to guess is that you have to tell me how many whole numbers, how many significant numbers are in this whole number. Alright, so there are actually four significant figures which are the whole numbers itself, which is 1, 3, 2 and 5. Now moving on to our last rule, which says that zeros after whole number zeros are significant. What does this actually means? That zeros after whole number zeros. Whole number zeros is, for example, 12,003 12,300. Now if for example there's a decimal point after here, if there's a decimal over here, then automatically these zeros become significant. If there isn't a decimal, for example, if this number would have been 12,300, it wouldn't have been significant, these two zeros. But when there's a decimal here, now these zeros will become significant as well. And let's say there is 0, 1, 2, 5 here, so in this case this zero would also become significant, as it is coming is in between these whole numbers. So in this case the zeros within the decimal or whole number range are significant. And that's all from the video, and that was the last chapter of whole unit. If you have any sort of query or questions, you can ask me, and I'll make sure to answer it. Make sure to like it if you have learned, and subscribe. Thank you.